Yes, I'm audible to you.
Yes, sir. Sir, good evening, sir. I am here.
Yes, good evening. Also, same to you. Happy Diwali to you. Next, introduce yourself.
Sir, I am Orkuvanna. I am from East Midnapur, West Bengal. I have completed my schooling from native school, Vivekananda Vishwasam Sikhavan, and then my BSc from Velu Ramakrishna Mission Vidyamati. And after that, my master degree from IIT-BOMBAY. And I have my hobby is to motivate local students and also to teach them and also to go into the.
Yes, good. Last day we have discussed analytical. Some part is left. Yes, no.
Yes, sir. You have written that analytical part left. You will listen.
So today, which topic you have prepared for mock?
Sir, I have prepared, sir, 2-3 days ago all the analytical things. 3-4 days ago. 4 days ago. I have not read today especially.
Today, which topic you comfortable for mock?
Sir, you can ask anything.
Anything. Okay. I think last day we have left part of instrumental.
Chromatography. Yes, sir. Chromatography you have completed and asked some question from instruments.
Yes, instrument method of analysis. Yes, thermoanalytical and thermomechanical. The left part. Yes. The next
Sir,
go through.
sir, except thermogravimetry, you can ask. Thermogravimetry, I have not. Thermogravimetry, I have not.
यस हमने लास्ट डे कहाँ तक कंप्लीट किया था आइडिया है आपको
Yes, sir. Instrumentation, you have asked about UV. You have started.
अच्छा
You
यूवी
have just started. Yes.
स्पेक्ट्रोस्कोपी यूवी यस आई
Yes,
थिंक
sir.
सेक्शन इज कंप्लीटेड यस ना
Sir, what completed?
एएस एईएस आईसीपी
Yes, yes, sir.
कंप्लीटेड ना यूवी स्टार्ट यस
Completed.
स्पेक्ट्रोस्कोप टुडे टॉपिक इज स्पेक्ट्रोस्कोपी यस यस व्हाट द मेन एप्लीकेशन ऑफ यूवी
Sir, UV is a absorption spectroscopy and it mainly used for knowing any sample what the group is present is in there. Means which type of group is present we can know from it like into pi star or pi to pi star transition or in this region which group actually exists. That is 180 to 700 nanometer. 180 to 700 nanometer, it's actually measurement. It can measure. So in this measurement, which energy gap is there, and we can detect any molecule and this type of molecule which have this type of region, and also its quantity by the epsilon value. That
yes what the source of uv source
sir, hydrogen discharge lamp, deuterium lamp, and xenon lamp. These are these. And in this xenon or hydrogen or deuterium, we actually by a pressure we put these gases and to from there the light is in.
yes good next one is bl lambert law what the main application of bl lambert law
Sir, main application B.L. law says that absorbance is proportional to concentration and length of the cube. So main application is to from this we can know the epsilon value. Epsilon means that is the transition probability. So epsilon actually indicates that transition probability. Is transition is happening or not. So by the from the graph that which is this that is if we made the graph absorbance versus concentration graph, so we can easily detect, and if we know the L value, so we can easily detect the epsilon value. So from the epsilon we can tell that this transition is happening or not and in which intensity it is happening. And also we can know about the molecule from this also.
what the formula of bl lambert law can you describe
Yes, sir. Absorbance equal to epsilon into C into L. So absorbance is proportional to concentration, and absorbance is proportional to length of the cubate or any other things which we are using there. So it is actually it is proportional to concentration and also the length, means in how many way light is passing through this. So both it is proportional to both the concentration and the constant is there epsilon. So absorbance equal to epsilon into C.
Yes. A is equal to epsilon CL. What the meaning of this term in BLM word?
So meaning that absorbance is proportional to concentration, means if we increase concentration, absorbance will be more, and absorbance also proportional to length of the cubate. So if we increase the higher length of the cubate, then absorbance will be more, because if the length is high, so light is passing through a large way. So in large way, there will be the more molecule it will collide, and if it collides with more molecule, the absorbance also of the light will also be more. So in this way, absorbance equal to epsilon into C into L, and the proportionality constant each epsilon is there.
Yes, good. What the limitation of BL law, Lambert law?
Sir, that curve does not follow always the straight line. In higher concentration, it may be curved, because in higher concentration, all the molecules cannot absorb the light. So in some molecules are in the buried place, so they are it may not absorb light. So we cannot get a straight line in higher concentration for BR Lambert. So if higher concentration, if it is any sample is in higher concentration, we cannot get the absorbance value from the absorbance value. We cannot get the concentration of it. So
Yes.
it is useful for lower concentration, but not useful for higher concentration.
Yes, solution should be dilute. One
Yes, sir.
major limitation. Next, move on electronic transition. How many type of electronic transition present in UV?
Sir, N to pi star, pi to pi star transition mainly present in
Sigma to sigma, pi to pi, n to pi.
Sir, sigma to sigma star is not in the region of U. Maximum sigma to sigma star is not in the region of,
Yes,
and
yes.
del to del star also not.
Yes, pi to pi star, n to pi star is UV. Yes,
Yes, in the region of
UV. Which one is allowed and forbidden transition in?
sir.
Which one is allowed and forbidden transition in UV?
Okay, sir. Allowed and forbidden transition are mainly that is which follow spin selection rule and Laporte selection. So for electronic transition, it must be have to Laporte selection rule, follow Laporte and spin selection rule. Laporte selection rule says that del L must be have to plus minus one. Spin selection rule says that del S have to be 0. So for any type of electronic transition, these two rules must have to be satisfied.
Next, what the difference between chromophore and oxochrome?
Sir, chromophore means this type of molecule which can absorb UV light, and oxochrome is this type of molecule which is not actually active, not actually UV active, but when we attach some chromophore, it can means it increases the absorbance or increase. So if we use means some add some chromophore with oxochromes, then it can absorb UV. But in a single way, oxochrome cannot UV act. So if we add some chromophore with oxochrome, so then it is UV act. Like benzene is not UV active, but if we add OH group to it, then it can be active. So benzene is a oxochrome. So benzene ring is a oxochrome. but it is not UV active. But when we use a OH group attached to it, so then it will be the UV active. So it is the difference of the chromo. And chromophore
Yes.
means CO group or C double bond C group. These are chromophore.
Yes, good. Next, UV spectrum and shift in absorption band. How many shift and how many type of shift in UV spectrum?
So bathochromic shift and blue shift, red shift and blue shift.
Yes, what's the difference
Bathochromic.
of red shift, blue shift, hyperchromic, hypochromic?
Yes, sir. Red shift is that if the energy gap decreases, then it will absorb light of low energy. So uh, compound will absorb at higher means higher wavelength. So higher wavelength means it's safe to the red. And if the energy gap increases, so absorbance will be the absorbance will be lower energy, that is from the blue shift, it will transform to the blue shift. And hypsochromic shift is that hyperchromic and hypochromic shift are also there. So due to the change in certain factor, if the intensity or probability of absorbance increases, so then it is known as hyperchromic shift. And if the intensity of transition is decreases, so then it is known as hypochromic shift.
Yes, good.
So example of hyperchromic CD, if we use phenol, and then it is absorbance will be low, but if it is in the some basic concentration, basic condition, so it will be the C6H5O minus. So if there is O minus, more resonance will happen and epsilon value will be increased, so it will be transformed into hyperchromic shift. And in case of hypochromic shift, that something like aniline, if we use the acidic medium, so it will be the NH3 plus, and then epsilon value will be the decrease because conjugation will be the decrease. So it is an example of hypochromic shift. If we use aniline in the acidic medium, so it will show hypochromic shift because epsilon value will be the decrease.
Yes, good. Yes, two questions from my side. First question is, aniline show blue shift in acidic medium. Why?
Sir, same things, sir, because aniline in the acidic medium, it will be its NH2 will be converted into NH3 plus. So conjugation will be the decreases. So when conjugation will be the decreases, energy gap will be increased. So energy gap increase means energy of higher energy needed. So blue shift we have. So blue is the higher.
Yes, good. Next one question is, phenol show red shift in alkaline medium. Why?
Yes, sir. In alkaline medium, phenol group C6H5 OH minus will O minus will be converted. So O minus will be converted means conjugation will be more. If more conjugation happens, then energy gap decreases, and energy gap decrease means energy of light of low energy is needed. So low energy light means red light. So red shift happens. Conjugation mainly increases. So energy gap decreases.
Yes, good, red shift. Next one is, what the main application of Woodward-Fisher rule? What the uses of Woodward-Fisher rule in UV visible spectrum? Describe.
Sir, from actually Woodward-Fisher rule, we can get the epsilon value. That is the and also the transition in which actually there that the nanometer which range a molecule can absorb. So main thing we can know that in which range the molecule will be absorbed light. So there is a rule in which group can absorb which type of light. So from that we can get a lambda max for any unknown compound.
Yes. What the difference between homoannular and heteroannular dynes?
Sir,
Homoannular and heteroannular dynes.
Okay, okay. Sir, homoallunar means that is the uh, that is the two double bond is in a ring, and heteroannular means two double bond are in another, means two rings are there. If two double bonds are in a single ring, then it is called homoannular, and if the two double bonds are in a different ring, so it is called heteroannular.
Yes, good. Basic. Any limitation and drawback of Woodward-Fisher rule in UV?
Uh, it cannot be always give right answer, because if there is something, it is actually approximate value, so it is not always true. So if there is some additional conjugation happens, or pH may be something different, or some other factors like condition temperature, on the basis of temperature molecular environment will change, so some, in that case also the lambda max value will be different.
Yes. Next one, how many type of absorption band in aromatic system?
How many type of absorbance means I don't understand the question.
K band, R band, B band, E band. Do you have any idea about this type of band?
K band, R band.
K band present
Sir,
in alkene system pi to pi star. R band present in N to pi system carbonyl complex. B band present in
okay, okay,
pi
sir.
star
In
aromatic.
that way, I don't know, but in benzene ring there is pi to pi star transition is present there, and only pi to pi star transition is present.
E band, yes, E1, E2, yes.
Yes.
Next is what is transannular effect in UV?
Transannular effect.
No problem, you look them, you have to read it, yes. Next, any drawback of limitation of UV visible? I will send you the answer, no problem.
Sir, from UV visible, actually we get approximate answer that which molecule can absorb which light. So in this region, actually many molecules can be present. So we cannot say from UV confirm that if this type of molecule is present there. So if any type of conjugation happens, or different type of group can have same lambda max value and same epsilon value. So we cannot detect any type of structure from this. We can actually finalize that this molecule is that, and from there we can actually finalize anything, or can know about the lambda max value, but we cannot say that from UV, that we cannot specifically say that this molecule is actually this.
Yes, basic. Yeah, next move on infrared spectroscopy IR.
Yes, sir.
What the main application of IR?
Sir, IR is applicable for functional group detection. So from this IR value, we can detect any type of functional group approximately. So for it is absorbance spectroscopy, and different type of functional group actually absorb different type of light range. So from this we can easily say that easily we can detect any type of functional group from higher spectrum.
Yes, what the source of IR?
Sir, Nance-Fluor, sir, Nance-Fluor is a oxides of zirconium and yttrium and erbium. So Nance-Fluor is the main source, mainly used as a source, and also there is a chloride. So Globar is a rod or sintered silicon carbide, and diameter is 4 nanometer and length of 50 nanometer. So heating is required to produce 1300 to 1700 degrees centigrade, and less intense IR radiation uh, uh, from the globe. And also we can use Nance fluid. It is also its diameter of 2 nanometer diameter.
Yes.
And Nance fluid emit more intense light than globe.
Yes. What the difference between fingerprint region and function group region?
Yes. So fingerprint region is specific for a specific molecule, and it is fingerprint region from 400 to 1400 centimeter inverse. So in this region, any type of molecule cannot be similar. So for all type of molecules, this region is different. So it is a specific region, and in this region, any type of functional group does not present, and functional group present mainly 1400 to 4000 centimeter inverse region. So in this region, actually different type of functional groups are present. So from this region, actually we can detect any type of functional group by IR switch.
Yes, good. Next is what is molecular vibration and how many type of molecular vibration in IR?
And molecular vibration is any type of molecule present in environment. It can vibrate or stretches or bend. So there is a different type of molecular vibration: symmetric stretching, asymmetric stretching, bending, rotating. This type of stretching are there.
Yeah, stretching and bending.
Yes.
Stretching in how many type and bending?
So stretching, symmetric stretching, it may be symmetric or it may be asymmetric stretching. And bending can be in a plane bending or out of plane bending. So,
Yes, in plane is
sir,
in plane. Which one is in plane and out of the plane? Bending.
yes, sir. Bending may be in plane bending or out of plane.
Yes.
Sir,
In plane, how many
sir,
type?
oh, in plane maybe two types, sir. I have forgotten. That is seesawing or something else. Seesawing.
Showing rocking. Yes.
Yes,
And
sir.
out of the
Seesawing.
plane, wagging and twisting.
Yes.
Next one is what is degree of freedom?
So degree of freedom means actually uh, degree of freedom we can calculate by the formula 3n minus 6. So degree of freedom that is for transitional there is a 3, and for rotational there is a, if the molecule is linear, the rotational degree of freedom is 2, and if it is non-linear, so it have degree of freedom is 3, and the remaining part, that is 3n, if the molecule have n number of atoms, so 3n minus 5 is the number of degree of freedom for that is the linear molecule, and 3n minus 6 is the number of degree of freedom for non-linear molecule. And degree of freedom actually indicate that if a molecule is rotating or bending or stretching, so in how many direction it have ability to freely go. So from degree of freedom, we can know that in how many direction a molecule can easily rotate. Actually, means easily go. Actually. So, and we can get from the value of it by the formula.
Next one is vibration frequency. What is vibration
Yes,
frequency? What the formula and what the uses of this one in IR?
sir. Vibration frequency nu is equal to 1 by 2 pi root over k by mu, sir, and k is the uh, binding constant, and mu is the actually formula weight of the molecular weight of this of any type of molecule. And so from this we can easily detect that easily calculate the binding constant K value from this. If we know their new value and if we calculate the new value, so we can easily get the K value, that is a bond is how strong a bond is. From the K value we can detect that a bond is how much strong.
Next is, what the selection rule of harmonic and harmonic oscillator in IR?
Selection rule. So selection rule, that is the change in the dipole moment must be not equal to 0, and also it is the main selection rule, and specific selection rule, that is, and the gross selection rule is d mu by d and not equal to that is the same thing, d mu by d. So it is mainly that d mu by d are not equal to 0. This is the main selection rule.
Yes, plus minus 1 is harmonic, and plus minus 1, plus minus 2, and plus minus 3 is anharmonic selection rule.
Yes, sir. It is gross selection. The gross selection rule says that plus minus 1 is for harmonic oscillator, and anharmonic oscillator it may be plus minus 1, plus minus 2, plus. Yes.
What is Morse curve? The Morse curve in IR.
What is?
Morse curve, Morse, M-O-R-S-E, Morse curve.
Okay. So Morse curve is says that the harmonic oscillator potential is not equilibrium. So a molecule can be, so if it is harmonic, totally harmonic in nature, so then a molecule cannot break anytime. So, but Morse, from the Morse potential curve, it actually indicates that anharmonicity of a molecule. So if there is anharmonicity of a molecule, so it can be break apart. So Morse curve is not like a single harmonic oscillator curve, that is a so it has some potential break in there, and from that we can easily detect that in which range a molecule can break apart.
Yes, what is hot band? What the main hot band?
Yes, sir. Hot band is the transition. If the transition is happens from 2 to 3 or 3 to 4 transition, or in the vibrational rate, then we can get hot band. That actually main, if there is all type of molecules are present in the lower vibrational state, that is V equal to 0 state. But if some molecules are also present in V equal to 1 or V equal to 2 state. So if 1 to 2 transition happens or 2 to 3 transition happens, then we can get the hot. And 0 to 1 transition, for 0 to 1 transition, we get the main fundamental.
Yes. What is Fermi resonance?
Sir, what is?
Fermi resonance, Fermi.
Okay. Sir,
Yes, Fermi resonance.
sir, means if two means
Fundamental and first overtone.
when multiple, sir.
Yes, fundamental band and first overtone mix.
Fundamental band and first overtone.
One fundamental band and one overtone. Yes. Mix yield to called Fermi resonance. Do you have any idea about Fermi resonance?
Sir, I just forgotten the term actually where I agreed.
Okay, no problem. You look them and you have to study about this. Yes. Yeah, I will send the answer. The next one is what the uses of IR spectroscopy in our society and human being. Any 4-5 point beneficial. The beneficial point.
So uses of IR spectroscopy.
Yes.
Sir, to detect any type of functional group, mainly we can use IR spectroscopy, and to detect any type of unknown sample present in a mixture. So it also be useful to detect it through IR spectroscopy. And from IR spectroscopy, it is for determination of newly made compound. It is also used in laboratory uses. So, but from IR spectroscopy, we cannot confirm that a certain group is present is there or not.
Yes, any drawback limitation of IR?
Yes, sir. From IR, we cannot detect that if we cannot say that a certain type of group is present or not, because various type of molecule have the vibrational the energy frequency nu bar is in the same region. So we cannot 100% with surety we cannot say that this type of functional group is present or not. This is the main drawback. So it is the not a test for actually not a certain taste that from which we can easily say that this functional group is must be present is there. But from this we can get an idea that this molecule, this type of group is present or not. So it is helpful then for analysis through NM. But from this we cannot 100% surety we cannot say that this group is present. Sir, I just remember that Fermi resonance. Fermi resonance actually said that if two molecules are present is there and one's fundamental brand is matches with another molecular fast over, then the Fermi resonance is happening.
Yes,
I
yes,
think.
yes, right. Yeah, next move on. The next spectroscopy. Yes, so other question is any limitation drawback of IR?
So limitation I had said just now.
Yes, yes. Next is mass spectrometry. What the main application of mass spectrometry?
Sir, by mass spectrometry, we can detect the molecular weight of any unknown sample. Uh, this is the main application of this. And the fragmentation also we can, how the molecule is fragmented.
Yes, molecular weight determination, elemental analysis.
Yes.
Next is what the difference between molecular ion peak, parent ion peak, base ion peak in mass.
So base ion peak is the most intense peak in the mass spectroscopy, and molecular ion peak is the main molecular weight of the molecular ion. And another thing, what you have said, so base peak is the most intense peak, and molecular ion peak is the peak which is the molecular, which indicates the molecular weight of it.
Yes, molecular ion peak and parent ion peak is same.
Yes.
Next one is meta-stable ion peak. What is meta-stable ion peak? Other one also.
So metastable ion peak says that if there is any type of fragmentation, so from the fragmentation part, actually the peak which are arises, so these are metal stable. Or which peaks we don't see every time when we are fragmenting.
The next one is a nitrogen rule. Detection of nitrogen. First of all, basic is elemental analysis. How to detection of chlorine in a mass.
Sir, chlorine there we will see that in case of molecular analysis, there will get a 3:1 ratio of two peaks nearby, which have difference of molecular weight of 2. That is for the 35 Cl35 and Cl37, and their intensity ratio is 3:1. So from that we can detect that there is chlorine is present on.
Yes, chlorine, bromine, iodine.
Sir, for bromine we have there will be ratio of 1:1 intensity peak of a difference of two molecular weight, that is 80 and 82. So and their intensity ratio is 1:1. And from iodine also, for iodine there is a single peak. I think it's for iodine, I think, sir, there is a single peak. So we can actually differentiate iodine with chlorine or bromine by the molecular by the mass spectroscopy.
Yes. Next, detection of nitrogen. Nitrogen rule.
Sir, nitrogen we can detect by molecular mass of this. If it is divided by if we divided a group by CH2, that is 30. So if there is uh, if the molecular weight is in the means even odd number, so we can say that there may be a nitrogen present. So from the molecular weight, it is even or odd, we can say that if there is nitrogen present or not.
Next one is Mac-Lafferty rearrangement. What the main application of Mac-Lafferty rearrangement?
Magley-Fati rearrangement is a special type of rearrangement. So from this rearrangement, we can say that if a specific type of fragmentation is happening or not. So Magley-Fati resonance is it is a actually it is a specific type of rearrangement happens in a molecule. So from this we can easily get idea about that which type of fragment is present or not. So actually, the nitrogen rule says that I actually don't say it in a proper way. Sir, nitrogen rule said if there is a presence of nitrogen atom in a molecule, so if the molecular mass is odd, so then it contains an odd number of nitrogen, and if it is the even molecular weight is even, then it contains a even number of nitrogen. So it is the nitrogen rule actually.
Yes.
So firstly, we have to check if there is nitrogen present or not, and if nitrogen is present, so if the molecular weight is odd, then there is odd number of nitrogen atom. If molecular weight is even, there is even number of nitrogen atom.
Yes, good. Yes, next day we will discuss left part of spectroscopy. Yes.
Sir, yes, sir. Left part means, sir, please.
Rotational, ESR, EPR, NMR, vibration, rotational, Raman.
Okay, okay. ESR, EPR. Okay.
ESR, EPR, Moss, BR, NMR,